Look at a map of the Pacific Ocean and really look at it. It covers more surface area than every landmass on Earth combined. Somewhere in the middle of that ocean sit tiny islands, dots of land separated from each other by thousands of miles of open water, no coastline in sight, no reference points, nothing but sky and swell in every direction. And yet, roughly 3,000 years ago, without a single compass, without metal tools, without writing down a single chart, Polynesian voyagers began deliberately sailing out into that emptiness and finding those islands. Not drifting into them by accident, finding them on purpose, then sailing back home again to tell others how to follow. By around 1,000 years ago, their descendants had completed one of the most improbable feats of exploration in human history, settling the far corners of what is now called the Polynesian Triangle, stretching from Hawaii in the north to Rapa Nui, or Easter Island, in the southeast. Aotearoa, New Zealand, in the southwest, an area covering roughly 10 million square miles of ocean. For a long time, some Western historians assumed this had to be luck, canoes blown off course by storms, stumbling onto land by chance. But that theory falls apart under real scrutiny. Too many of these voyages were round trips. Too many islands, thousands of miles apart, share the same language roots, the same crops, the same cultural practices, evidence of intentional repeated contact, not one-way accidents. So the real question is not whether ancient humans crossed the open Pacific this successfully. They obviously did. The question is how, and a surprisingly large part of the answer had feathers. This was not unique to the Pacific either. On the other side of the planet entirely, Norse sailors pushing into the unmapped North Atlantic were relying on strikingly similar tricks. Different ocean, different birds, same basic problem, and, it turns out, a remarkably similar solution. Here's the core insight. Ancient Polynesian navigators built an entire system around. Certain seabirds nest exclusively on land, but fish far out at sea during the day, which means their daily commute is basically flying arrow pointing straight at an island. Spot one of these birds heading in a consistent direction in the late afternoon, and you are looking at a compass with wings. Frigate birds were especially valuable because their feathers are not fully waterproof, so landing on the ocean is risking drowning. They almost never do it, which means a frigate bird sighted at sea is, by definition, still connected to land, sometimes from as far away as 60 miles. White terns and noddies range closer, typically inside 30 or 40 miles, but return home just as reliably every evening. Pacific voyaging researchers described navigators reading this entire cascade. Frigate birds signaling land a full day's sail away, terns signaling it was much closer, boobies confirming a reef was practically underfoot. Birds were never the whole system, though, and it matters to say that clearly. Polynesian wayfinders combined bird behavior with a mental star compass, tracking roughly 200 stars across 32 horizon points, the feel of distinct ocean swells, moving beneath the hull, and even the green tint clouds take on when reflecting a lagoon below. For most of the 20th century, this entire tradition was assumed to be dying out. Then, in 1976, master navigator Maupaialug guided the canoe Hokulea over 2,300 miles from Hawaii to Tahiti using nothing but these traditional methods, no instruments at all, proving conclusively that the old system still worked exactly as advertised. Halfway around the world, Norse sailors pushing into the unknown North Atlantic developed their own version of this trick and one voyage in particular made it into the history books. According to the Landnámabók, the medieval Icelandic Book of Settlements, a Norwegian sailor named Folki Vilgerdarson set out sometime in the 9th century to find a distant land other sailors had only glimpsed. He brought 3 ravens with him, deliberately kept hungry, according to some accounts, so they would be motivated to fly straight for solid ground the moment they were released. He let the first raven go, and it flew backward toward the land they would already left. He released the second, and it circled uncertainly before landing right back on the ship. But the third raven flew forward and never returned at all, which told Loki everything he needed to know. He followed its flight path directly to Iceland. From that voyage on, he was known permanently as Rafna Raven Folk. Norse sailors reportedly also studied auks along the coastline, birds whose behavior gave away their intentions with almost comic simplicity. A bird flying with an empty beak was heading out to fish, while one flying with a full beak was heading home to its rookery, straight toward land. What is genuinely remarkable is how far this same basic idea traveled. Ancient seals from the Indus Valley civilization, thousands of years earlier, depict boats carrying crow-like birds on their bows, and Buddhist texts describe Indian Ocean sailors keeping a caged bird called a disha-kaka or direction crow. Released specifically when a ship lost its bearings in open water. Completely unconnected cultures, separated by oceans and centuries, independently arrived at the exact same solution. When you are lost, let a bird decide. None of this worked by accident. It worked because certain seabirds are, biologically speaking, creatures of habit. Species like frigate birds, terns, and boobies are central place foragers, meaning they always return to one fixed nesting site, day after day, which makes their flight paths remarkably predictable compared to almost anything else moving across open water. A drifting log does not reliably point toward land. A bird that must return to its colony before dark does, at least during certain hours, and only within its normal foraging range. But the last detail matters, because this method had real limits, and ancient navigators clearly understood them. Far from any island, in the true open ocean, there was no shore bird to spot at all, which is exactly why birds were always paired with stars, swells, and long-held oral knowledge passed from teacher to student across generations, rather than relied on alone. Migratory birds added a separate layer entirely. Some Polynesian navigators reportedly timed long voyages to follow the seasonal flights of species like the Pacific golden plover, understanding roughly where those birds bred and wintered, long before Western science formally mapped the same migratory routes. What this really represents is centuries of extraordinarily close, patient observation, passed down and refined by people who had every incentive in the world to get it right, because getting it wrong meant dying at sea. They could not explain the biology of central place foraging or waterproofing on feathers. They did not need to. They only needed to know that this particular bird, flying this particular way at this particular hour, meant land. And when Hokulea completed her voyage in 1976, she did not just revive a forgotten skill. She proved that an entirely bird and star-based navigation system, developed with no writing, no metal, and no instruments, was accurate enough to cross one of the largest oceans on the planet, and still is. From the frigate birds of the Pacific to Florke's ravens in the North Atlantic to the direction crows of the ancient Indian Ocean, the The same lesson repeats across every sea humans dared to cross. Watch the birds, and they will show you where the world keeps its edges.